Our goal is to build big family domes, right? Like 2, 3 domes that connect together that are anywhere from 1,500 to 3,000 square feet. And also the smaller, spaces. A lot of people want 400 square feet or 800 square feet, and all that can be kind of done efficiently with this domes of 2 and then 3 different sizes that can interconnect.
Is a carbon-neutral ceramic geodesic dome with a 500-year lifespan the future of housing in America? Welcome to TechFirst. My name is Koetsier. 3 years ago, I wrote about this funky crowdfunding project to create a new kind of home. 1 year ago, sort of in the tail end or middle of COVID still, I wrote about the progress and some early prototypes. And lots of people on YouTube said, "Where's the beef? Show us. Is this real or is this vaporware?" Well, today I'm with the founder of Geoship, Morgan Bierschenk, and as I understand it, he's going to show us the beef. Welcome, Morgan.
Hey, John. Yeah, so good to talk to you again.
Good to see you again. I see you're in a place. It doesn't look like a virtual representation. Where are you?
Yeah, we're in our first engineering prototype here in Nevada City, California, the ceramic geodesic dome.
It looks impressive. It looks different from some of your earlier prototypes. I don't know if you've painted it or what you've done. Can you give us, I know you're sort of tethered. It's not a mobile device you're sharing right now, but can you give us a bit of a tour as much as you're able of what you're inside?
Sure. Yeah, so this is a 18-foot diameter ceramic geodesic dome. So the frame, the exterior, the interior are all ceramic composites. There's no paint anywhere. And I'll do a little bit of a swing around here. I've got some lights here to try to reduce the shadows, but kind of get us. It's not a huge space. The main intention here is really to, prototype all of the engineering and design challenges and material science challenges. There's a lot. This is a pretty major innovation in terms of we're not using any metal, wood, concrete, or petrochemicals. It's just all a new material science. It's a chemically bonded ceramic that we're basically injection molding and press molding in a factory.
You said no metal, no wood, no paint, and there was another no in there, if I'm not mistaken.
Petrochemicals.
Yep. Okay, looks incredible. I want to talk about that in a bit. I want to talk about the windows and the natural light and all that stuff. For those who are seeing this for the first time, didn't watch the first video, didn't watch the second video, didn't read the story on Forbes, tell us the story of Geoship. You talked about it a little bit in terms of the new material science, but what are you trying to achieve here?
Yeah, we're really trying to introduce a new archetype of home with the climate crisis combined with the housing affordability crisis and kind of the, crisis of disconnection, for lack of a better way to describe that, just community building, needing more community. This technology, we think we're really starting from physics first principles. So what is in home building, it really comes down to material science, geometry, and method of manufacturing. And so we chose the most efficient in all of those areas, right? The geodesic dome, chemically bonded ceramics, or otherwise known as geopolymers, and injection molding. And you combine those 3 together, and I think this has huge potential for being just a transformative home building technology for the future.
We talked about last time that you wanted to build something with potentially a 500-year lifespan. Talk about the material you're using here. People think ceramic. I don't know what they think. Do they think, teacup or something like that? What is this material here and what makes it so durable?
Yeah, so it's a chemically bonded ceramic. It's a new material science that was really developed at U.S. national labs through the early 2000s by the nuclear industry. And now it's been commercialized over the last 20 years in quite a few different industries. It's actually a bioceramic used in the human body for bone repair. It's also used for infrastructure repair, like concrete and bridge repair. Highway Department of Transportation is using it quite often, and also for steel coatings. So you can spray it on steel and it actually is like a paint that bonds to the steel and alloys it. And so that kind of hints towards how it's really different in terms of it kind of sits in the middle of a ceramic, a cement, and an epoxy, and that it has all the properties of a ceramic, but it doesn't require high heat. It is like a flash cure at room temperature, so like a really fast acting cement, and it has the properties of it's technically an inorganic polymer. So like an epoxy, it forms molecular bonds with metal, wood, and itself.
Pretty amazing stuff. It's used actually inside the human body, which makes you think, okay, it's pretty healthy stuff. It's not going to poison you or do other bad things to you. I see obviously the triangular shapes. Is that your injection molded shape, and is it kind of like Lego blocks? Can somebody get them and put it together themselves?
Yeah, that's our goal, is to really provide a kit of components that people can either, a trained crew could install it really quickly, or kind of an owner builder could do it on site there's no cutting, there's no measuring, the parts only fit together kind of one way. Can also be kind of assisted with like augmented reality glasses to have a little helper there, or the parts kind of light up and show you where they go. And that's where you see it. I think this generally there's some big, major momentum happening, I think, in the home building industry in general. And the direction is pretty consistently like parts are manufactured in a factory and assembled on site.
Talk about the windows. One of the things, I love natural light. Where I live on a mountainside. I see trees out. When I look out, we have large windows. One of the things that struck me as you sort of did your little twirl there, was natural light and windows all throughout. It's amazing. But you said there's no steel, there's no wood or anything like that. How are those window components created? Do they have the ceramic around the actual glass?
There's a little bit of a steel spacer in between, like, from a window manufacturing company that makes the little spacer in between the glass, but the glass is set into a ceramic frame. And yeah, the whole, one of our key kind of design goals here, and it's really exciting to experience it actually for the first time. We've been working on this project for a long time, and it's just in the last few days that we got it complete enough where I could just be able to sit in here and really experience the space. And it's phenomenal. It really feels like you're being held by the earth in a sense. Like earthing is a combination of earthing floors, high dielectric ceramic materials, and these kind of great circle skylights that kind of make you feel connected to the outside, yet really held.
Interesting. So just for background, people may not know it. You're from the tech industry. I believe, I should have double checked this before. I believe it was Microsoft, or was it Intel that you worked for?
That was Intel.
It was Intel. Excellent. So you've got a hardcore science and technology background. And you talked about it a little bit there, but expand on that. You're in this space, and try and imagine, you didn't have the 3 years of trying to make this moment happen. Try and imagine you come in for the first time and you lay down in this space. What do you feel? How does it feel? There's something comforting about that circular, that dome space, isn't there?
Yeah, I mean, it feels, the two words are really centered and balanced, right? The energy, it feels really centered. It's almost like if you dance or do yoga or something, it's just the nature of the space. The energy is focused into the center. And then the earthing floors kind of make this connection, feel like a connection to the earth, and just eliminating all of there's obviously no mold and toxic building materials, and a lot of fresh air because you get vents at the top and vents at the bottom. So you have this natural convection process. And that's really our overall design goal, is how do we, restore the natural conditions that humans would have evolved with for thousands of years, right? In a modern, ultra modern architecture.
You've mentioned twice now earthen floors. What does that mean? Bare earth? Does that mean stamped earth? Does that mean some sort of ceramic on the floor? What do you mean by that?
It's basically a cob floor, and then we can put a layer of ceramic, like a ceramic veneer over it potentially. But this is just a pure cob floor, and there's a lot of science that's come out in the last couple of years, especially maybe 5, 10 years here now, of just the benefits of earthing. I mean, you can connect when you put your feet in the mud. There's actually a reduction in inflammation basically in the body.
Mm-hmm, mm-hmm. Talk to people about your vision, perhaps for a family or a community, a small community. You can join these domes. You can have one as like the communal kitchen dome. You can have others as bedroom domes. Talk about how that works.
Yeah, totally. That's one of the big kind of, I think, just misunderstandings that people have at some level now, because we're sitting in a small dome, and, we enter the market with a small dome because that's the wisest way to enter the market. But our goal is to build big family domes, right? Like 2, 3 domes that connect together, that are anywhere from 1,500 to 3,000 square feet. And also the smaller, spaces. A lot of people want 400 square feet or 800 square feet, and all that can be kind of done efficiently with this domes of 2 and then 3 different sizes that can interconnect.
It is interesting because I continually hear about it, not just through news sources, but also people that I know. People are looking for different ways to live, right? We've kind of come from this reality that maybe for thousands of years you had multiple generations in the same dwelling, whatever that looked like, whatever that felt like, to in the past, let's say 100 years, certainly 50, you move out, you might be alone in your space. You might be with one other person in your space. You might have a nuclear family in your space, and there's a lot of disconnection. So you see things in Berlin. They're doing cool things with former office buildings, that building a variety of homes, and then small bedrooms, big communal space. And in other places, I believe it was in Kentucky, there's a family that built 6 tiny homes for them, their kids, and their adult children. And it's all sort of congregated around a space of 5 acres that they put together, right? And so people are looking for a different way to live. How does this fit into that?
Yeah, I think a nice way to think about it is a new and ancient future. So in a lot of ways, the new technology that's coming out with Web3, being able to have a little more close interactive experiences, also opens up the potential to go back in some ways to like a village building model, where you can connect with the people that you want to build a community with in the cloud, and participate with one another in a digital space to kind of build the relationships, and also to design the village that you want to build, and then go through the design build process, kind of potentially form a DAO and local currencies, so you can really kind of we see, one of the, I think, great companies are often built on kind of general and surprising insights. And Geoship were really built on 2 general and surprising insights. One is that, like, in the future, not everybody will live in boxes. Like, round homes will just be a new choice that people will have, that isn't really a viable option today. And also, communities will populate the land from the cloud, right? So millennials are sort of the first generation of digital natives. And we think the way the development process will work in the future is that people will, have more participation in it. Today, it's like developers and banks get together and buy land and build homes and then sell them to people. And in the future, it's just natural that the communities will participate in that process and have more say in the design, so that the village is kind of an expression of what is important to them, right?
Cool. Talk to the listener or viewer who isn't into Web3, doesn't care about the cloud, doesn't want his or her feet in the mud. So the fuzzier stuff that you're talking about and the feeling that you're talking about doesn't matter to them. They're looking to build a place. They want it to be something that is eco-friendly. They want it to be something that's comfortable. They want it to be something maybe innovative, but they're looking hardcore at the atoms, right? Talk to them about this space and if this works for them.
Yeah, totally. So at a sustainability level, by using this material science and geometry, we reduce the carbon footprint of housing by about 90%. That's the embodied energy, the energy it takes to construct the home. And also this dome has about a 10-inch thick insulation cavity. So it's kind of super insulated, even beyond kind of passive house standards, because it's a lot of big insulation cavity combined with the reduced surface area of a dome, and combined with kind of the ceramic has a special kind of heat reflective property that gives it really next level energy efficiency. And then also the geodesic shape. I mean, as climate becomes a little more uncertain in the future, in terms of fires and floods and hurricanes and earthquakes, this structure is like, there's nothing to burn. Hurricanes, the most hurricane resistant structure you can build in terms of just its aerodynamic, and is also very high strength ceramic composites. So the ceramics are basically have carbon fiber or natural fibers embedded in them, depending on which component it is and what kind of strength we need. And also earthquake resistance. So there's no, what fails in an earthquake, I think it's important, like earthquakes don't kill people as much as buildings kill people, right? It's buildings that collapse in the earthquake that cause the catastrophe. And what fails in an earthquake is these moment connections where columns and beams meet. In a geodesic dome, you have this kind of tensegrity principle going on where there is no columns and beams. It's real
integrated whole almost.
Yeah.
Interesting. Okay, cool. So one of the things that I know that you've been working on is cost. That's obviously a concern for a lot of people in the world right now, especially in the Western world. Real estate prices may have come down slightly after the COVID surge, right? But it's crazy expensive for a lot of people. That's driving a lot of the tiny home stuff as well, where you can build a tiny home for, I've seen people build it as little for $10,000, $25,000, scavenging materials, other things like that. Where are you on the cost? I know it's early because this is your first like fully functioning actual dome. So you probably haven't gotten into economies of scale or efficiencies of production, but where are you thinking right now in terms of cost?
The base price for this 18-foot dome would be about $33,000. And the base price for a bigger kind of 1,100 square foot dome would be about $110,000. And that's not, as the manufacturing scales, our goal is to reduce those prices by at least 50%. And that's really the ultimate goal for Geoship, is to be able to build homes that are 2.5x median income in every location. And we think ultimately, because of this kind of first principles approach that I mentioned earlier, material science, geometry, method of manufacturing, at scale, we believe this form factor and material, this structure will be the most affordable and sustainable home at scale on the planet. So in terms of like, of course, building with local materials, like you cut down the trees on site or you use the dirt from the site and you put in a lot of manual labor, of course, that'll also always be a little less expensive. But in terms of like at scale, producing millions of homes, this technology should be the most affordable and sustainable homes on Earth at some point as we scale.
As you scale, that is, of course, the challenge. Building something that is excellent is the first challenge, and then making it producible at scale is the next challenge. Talk about where you are in that evolution.
Yeah, most of our, our first shot is to make the best home on Earth, the most affordable one. So there's a sequence there. Right now we're focused on making the best home on Earth. And that means for us, there's a lot of different, I know that's a subjective thing to say best, but there's a lot of objective ways we can measure that in terms of health and cost and sustainability and speed of construction and how long it lasts and all these kind of measurements to define best. So we're really focused first on building the best home over the next couple of years here. We're really designing for manufacturing. And then the challenge after we have the best home is to be able to produce it, to make it the most affordable home. And, that of course, it took Tesla to give you, I think Tesla Motors is a kind of a good benchmark for this kind of thing, because this is a really deep innovation in terms of new material science, new product design, new factory design. There aren't injection molded ceramic factories out there today. So we're developing that technology. And I think it took Tesla Motors 6 years to deliver the 100th car, and then 14 years to get to 1 million cars a year. And I think we're somewhere around that same trajectory. And of course, it's taken a lot longer to get to here because I'm not, Elon Musk with a lot of money and connection.
There's no emerald mine in your background. No PayPal millions. Shoot.
If I did, I put, we joke that we burned the boats, as far as my co-founder and I. We literally did. I sold my wood sailboat that I lived on to start bootstrapping Geoship. And we started in a barn on an island, and we're just have been full in, because we just know in our hearts and the kind of logically, the physics that we described there, that goes pretty deep. We have gone deep into that, just understanding, is this really the technology of the future? And we just really, really believe it is. So we're just in completely, and we'll make it, bring it, to the world.
And you've adopted sort of a community funding structure, right? Talk about that. And if somebody wants to participate, what do they do?
Yeah. I think that's the other thing that, we haven't gone. Most entrepreneurs go to venture capitalists and raise, a lot of money early on. And instead of going that route, we really saw, we want to, it's kind of crazy. It's a little bit of an unlevel playing field when it comes to like investing in private tech companies. And private tech companies pretty much generate like most of the wealth in the world financially, and early stage private tech investing was limited to accredited investors until 2016. So now that's opened up. And so now everyday investors can invest a minimum of like $400 in a company like Geoship and potentially see these big returns or potentially lose all your money. But we've been going down that route of like community first financing. So we've raised a pre-seed round through equity-based crowdfunding, and now we're raising a seed round. And we're also going to go out to more like family offices and angel investors, and maybe a few really purpose-aligned VCs. And there's also a lot of government funding that we're pursuing at this point, the kind of Inflation Reduction Act and whatnot. That's 10 times more funding available now for climate tech and affordable housing than there was in 2008 when Tesla got $400-something million to set up the first manufacturing plant.
Mm-hmm. Cool. Before we finish this, talk a little bit about how this connects to the rest of the world in a very physical sense. Water, electricity, other things like that. It seems like it would work well, sort of an off the grid scenario, maybe with some solar and stuff like that. But in most cases, it'll be on the grid. Is that part of what you're working on now? How it connects with those systems? How you build a kitchen in one of these, maybe in the larger ones, all that stuff?
Yeah. There's been some just beautiful innovations in that space from movements like the kind of Earthship, autonomous home design. And we're bringing in a lot of those principles in terms of like passive solar heating and cooling, and passive solar heating and cooling, and just other technology to basically create tools for people that are kind of plug and play, that generate power, recycle water, reuse waste, that kind of thing. But of course, fundamentally, if most built sites, it's pretty much the same. You've got sewer and water, plumbed to the pad, and this goes on, and the plumbing and electrical is pretty similar to conventional build. And you have a ceramic frame, and then you have the exterior panels that go on, and then you can run all your electrical and plumbing, and then you put the interior panels on and fill the insulation cavity.
Nice. And obviously you've got electrical up top. I see a lamp behind you. So you got ways of routing power and other things like that through the panels themselves, which, as you said, are pretty thick. It looks amazing. Maybe this summer I'll have to take a road trip and see one in person.
Yeah.
Thanks for sharing. Anything else to leave us with at the end?
I think main thing is go check out what we're doing. We're really have a big vision here for transforming, kind of creating an alternative home building and village building industry. And the experience is about the experience. I can't wait to bring more people in here where you can just like sit and take it in, because when you're in the space, it's pretty clear how this ceramic dome technology is really fundamental, right? You can see how this would advance incredibly in the future, and the experience of just being in the space. It's an ultra modern natural home, and I think it's unique in that way.
It's really interesting because in the same interview, you've said ultra modern and ancient, and both of those are true from different perspectives. I can't wait to see the village build and grow. And thank you for taking this time.
Yeah, thank you so much, John.